Hey there, today we'll be doing this question 797, all paths from source to target from Leetcode, and this is from the graph playlist. And this question is on the day 7, and all the other questions have already been uploaded. Please do check that out as well. And the I graph playlist link will be coming in the I button. Please do check that out from there as well. Okay, so it will be helpful for you and me as well. Coming on to the question statement is you are given a directed acyclic graph. Acyclic graph means that there will be no cycle, okay, of n nodes labeled from 0 to n minus 1. Find all possible paths from node 0 to node n minus 1 and return them in any order. The graph is given as follows. Graph I is a playlist of all nodes you can visit from node I, that is, there is a directed edge from node I to graph ij. So if you look at the constraint, you'll see that n is very small, that is n is less than equals to 15, and they have said you need to return all the possible paths. So you'll have to use backtracking here, okay? And backtracking, or you can just say DFS here. A simple DFS here would suffice as well. That is the same. So here you have to use backtracking, and there is actually a similar problem in lead code which is exactly this. I don't actually remember it, but if I do, I'll just pin that in the comment as well. But there is a similar question to this in trees and in recursion as well, as I think. So let's understand how to do this. So I've drawn this very ugly graph, I would say. So please just bear with me for this part. So let's understand how are we generating this using DFS. So you'll have to use DFS. That is very obvious in order to generate all the possible paths. But how to do it? So they have said the starting point is 0. Fine, you're starting at 0 and you need to return, or you need to go on to n minus 1. So if n is 4, for here you have to go till 3. Fine, so what are the possible paths? So let's understand this with a recursion thing. So at first you go to 0. What are the two possible paths? You can go to 2 or you can go to 1. So these are the possible paths right here. So what will I say? I will call a DFS or a recursion, whichever you like to call it, for either 2 or for either 1. Fine. After that, what are the other possible paths that I can reach? From 2, I can take this 3 path. So I'll take this path, and from 1 I can only take this one path, that is to 3. Now when you see, you have reached the n minus 1 node, that is n is equals to 4 right here. Fine, so n minus 1th node if you have reached, what do you need to return? You need to return all the cumulative nodes that you took in order to reach this n minus 1th path. And how many ways are there? Here there are two ways. So one way constitutes of 0 comma 2 comma 3, and the other way constitutes of 0 comma 1 comma 3. So this is what you need to return. Okay, so that is the whole question to go about it. And let's just understand, what if there is something other than this? What if there are multiple paths? What if I just remove this and I'll just say 2 cannot reach to 3? So what is the path that you can take? From 0 you can obviously go to 2, and you can obviously go to 1. But from 2 you can never reach any other node, but from 1 you can reach another node, that is 3. So the only possible path that you can take is 0, 1 and 3. Fine, so this is the whole problem go through. Let's understand this with code, because this is a simple normal recursion DFS type question. Fine, so there's nothing much to explain right here. Let's understand this part now. So right here, what I've done, I just created the answer vector that we need to return. After that, I've pushed back 0 in my temporary array. Why so? Because they have said we are starting from 0. Now there is a DFS call that has been made. Node is just saying that, okay, this is where I'm starting from. Fine. And n is what? N is nothing but the uh, we can say that it is something like just a reference to where we have to reach. So n minus 1th node is where we need to reach, so that is why I've taken a reference to n here. After that, we have just copied on the graph array that has been given to us. You need not create any other extra adjacency list. We can just travel on the graph that has been given to us only, and there is a temporary array, and there is path, and this path is what we'll be returning at the end of the day. And this temporary vector is just storing the temporary path that we are taking. So if we had something like this, so when we reach 3 using this path right here, the temporary vector would have this path contained in it itself. So in the paths vector, that is my final array, what will I insert? I'll insert 0, 1 and 3. Now when I take another path, I'll just change the graph right here. When I take another path that is of 0, 2 and 3, my temporary array will have that path. So I'll just insert 0, 2 and 3 into my paths array, and this is the list or array that we need to return at the end of the day. Fine. So I'm saying that if I reach n minus 1th node by some path, what am I doing? I'm pushing that vector into my final array. Otherwise, what we do, we just do a DFS, simple, plain old DFS that we have been writing since day one. We go in the graph, we go for its corresponding node, and we say that okay, I'm taking you and I'll push you into my temporary path, and I'll call for the other one. Otherwise, when I come back, I'll just pop this out. So this is a plain old recursion code. Okay, so if you have any doubt about this, please actually check out the recursive code for the I don't actually remember the problem name, but if I do, I'll just link that up again. Fine. So this is exactly similar code to that. If you actually can do that question, then this question will be a easy cakewalk for you. Fine. So I hope you have understood this, but if you did not, please do check out the recursive one. Okay, I'm just telling you and focusing on that recursion part again, because that recursion will actually clear all the doubts to why did I push back and why did I pop back. Fine. So this is a recursive concept that we have used here. So I hope that if you are doing this graph playlist, you have already done recursion, but if not, please do recursion first and then do this, then it will be very helpful for you. Fine. So I hope you have understood this code part as well, and if you did like this video and understood the code, please